whatever physical parameters are there, let's say temperature, let's say humidity, let's say rainfall in a space or in a place, all these things are modeled in a linear fashion, and we can represent all this system in ordinary differential equation form, because all these things have to be a continuous time parameter. So if you see sunlight, if you see wind fall, if you see the temperature at any place, humidity, rainfall, all these things are continuous time process. That means there is no break. There is no break in the sunlight. Okay, in the evening time, sunlight is not there, but in that time, the value of sunlight is equal to 0. But totally things are absent. It doesn't happen like that. So everything is having a continuous value, and whenever the system is continuous time system, in that case we represent the system by using ordinary differential equation. So in your first year, second year, you have done ordinary differential equation and how to solve that. Those fundamentals will come handy for system modeling. So in control system study, such mathematical equations for a certain system is called a system model. Pandemic is going to end. How people know it? Because first they check what are the variables. So temperature may be a variable, mob crowd, that may be a variable. Okay, and how the people are behaving, going here and there, whether the market is open or closed, that is a variable. All these variable and their effect are mixed together in a mathematical form, and a mathematical model is derived out of it. And then we give certain kind of input to the model, and we derive certain kind of output. So whenever in control system, each study of any physical environment or domain or parameter, they are done with the help of a mathematical model. Now, how mathematical model help you? We can give any kind of input to the mathematical model, and it will give us probable output. So there are various types of system models, such as transfer function based model. So yesterday, I think I have uploaded that PPT. I asked you to check. So we were doing the introductory part of transfer function based modeling. So one RC system modeling we have done, and after that I have uploaded this video. Please check. That is, what are the advantages, disadvantages, what are the limitations, what are the applications of transfer function based modeling. So there are many types of modeling possible. One model is transfer function based model. Another modeling is impulse response based model. Then in the fifth chapter of our syllabus, we will find the state variable system modeling. So state variable system modeling is something which we are doing by using MATLAB or subspace based method, or by using computer. So in digital domain, when modeling is done, it is done by using state variable modeling or state space based modeling. So which type of model is to be selected? That depends on what type of process we are addressing. It is not that every process can be modeled with every method. Not necessary. Yesterday I had given you the example of highly dynamic system. So what is a highly dynamic system? Stock market, share market is a highly dynamic system. In that case, we cannot use a linear model. We cannot use a transfer function based model in case of the modeling of stock market. In that case, we have to go for very smart type of, maybe artificial intelligence modeling, or we have to do some genetic algorithm based modeling, or maybe fuzzy kind of modeling. Those things are required. So it depends on which parameters you are tracking, how fast they are, how slow they are, how changing they are, what is the dynamics of these parameters. All these factors have to be taken into account to decide what kind of model will be suitable or most suitable to track this process mathematically. So choice of a model type for representing a certain process or control system depends upon the complexity of the process. So yesterday we talked about nonlinear system. So all the systems you have studied in your signals and systems and all, and you are still studying, mainly all the systems are linear and time invariant process. But if you see physical world, maximum processes are nonlinear and they are time variant, and it is very difficult to control nonlinear and time variant process. So in that case, what kind of modeling would be most suitable? So representing a certain event or representing a certain process, what kind of model is most suitable? That comes with our experience, or there is certain guideline. So type of mathematical tool used to describe the process. Okay. So further we have to learn many different tools. So we have to learn transfer function based modeling, we have to learn impulse response based modeling, we have to learn state variable based modeling, so that we can track or we can mathematically represent any kind of systems. As you will grow up in the field of control system, you will be finding that nonlinear system modeling will be more suitable for physical parameter measurement. So if a model closely resembles the process, so when the mathematical equation is closely resembling the process, that means what? We know the last 20 years rainfall data in Belgaum, and we can find a mathematical equation or mathematical model equation out of that. What may be the parameters? Temperature may be the parameter. Humidity in Belgaum may be a parameter. What all rivers and ponds and all lakes are there around Belgaum? That is a parameter. How far Belgaum is from the river? That is a parameter. And every variable is having some effect on the rainfall at this place. Okay, now we have to represent the rainfall in Belgaum as an equation. So whenever equation is there, there's a coefficient and variable. Suppose 2x1 plus 3x2 plus 7x3 plus 8x4 likewise, where x1 can be temperature, x2 can be humidity, x3 can be its distance from seashore, x4 can be the lakes and all which are contributing to the rainfall, all these things, and they are having certain coefficients 2, 3, 7, 9. So modeling any system is actually finding the coefficient value and the variables which are contributing to this factor. Now, if I am saying that temperature at Belgaum, can you mathematically model temperature at Belgaum? So one very important factor in that case would be the factories around Belgaum, because Belgaum is having a lot of factories and they are continuously throwing out very hot air in the environment. So presence of factories, a number of industries around Belgaum, definitely it will add to how much is going to be the temperature of Belgaum in this summertime. So this is actually correlating the different variables with the actual parameter. So after finding the overall equation that which all parameters are contributing to the temperature or rainfall, now would like to predict that okay, we have 20 years data. From that 20 years data, we have found a model. Model means equation. Now we want to predict what is going to be the rainfall in Belgaum in 2021. So all these things are possible only if you are using computer, if you are using MATLAB, or if you are using mathematics for analysis as well as prediction. So without mathematics, you cannot go anywhere. So all these predictions, analysis, all these things are not possible without mathematics. So mathematical model, it's written here, closely resembles the process, but the model cannot be analyzed with mathematics. Then the model is not much useful. Okay, so if we find that if the model is closely resembling the process, but whatever result it is producing, we are not able to analyze it, then that model is not any use. In the second case, if you are finding that it's very easy to analyze the model, that is whatever results we are getting, very easily we are able to find out some inference from that. But the model does not resemble the process closely. Does not resemble the process closely means we are predicting that tomorrow the temperature will be 30 degrees centigrade. How can we predict it? By last 1 or 2 months data, temperature data in this region, we will fit it into a model, we will get a model equation, and then we are asking for a prediction. So suppose making the model is very simple, it's a very simplistic model, but it is predicting that tomorrow the temperature will be 5 degrees centigrade, but actually tomorrow's temperature will be 40 degrees centigrade. So sometimes what we do is we make the model very easy, but whatever output it gives, it is full of error. That is not expected. Second case, what we are doing is we are making the model very correct, very complex, but whatever output it is giving, that output we are not able to analyze. So both are not required. So model should not be very complex. In that case, analyzing the model becomes very difficult. Model should not be very easy. Model should is very easy means it is just taking 1 or 2 parameters, whereas the temperature is depending on 10 parameters, but model is taking only 1 or 2 parameters. It is not considering 8 parameters. In that case, whatever output the model is giving, that is full of error. Prediction becomes wrong. So these are two downsides of modeling. So if you have pen and paper, you can write down number one case. Model is very complex. Model is very correct. But whatever output it produces, that output we are not able to analyze. Teacher is very good, but whatever teaching he is doing, we are not able to understand. No use. Okay, that is the first case. Second case, model is very simple. Okay, it gives output, we can understand that. But whatever output it is producing is wrong. So both these cases are not expected. So similarly, if a second model, so second case it is explaining, it is easy to analyze, but it doesn't represent the physical system correctly. That means it produces error. Then such model is also not useful. Hence, a system mathematical model must be very close to the process. That means whatever output it is giving, whatever prediction it is doing, that should be very close to the actual process. This is the first requirement. As well as it can be analyzed easily. So model should be correct. That means it should be producing correct output. That is the first requirement. And second requirement is we should be able to analyze the output of the model in a very easier manner. Okay, so both these things are very important. So if you have pen and paper, you can write down these two things. What are the main characteristics of system modeling? First characteristic is it should be correct. Whatever output the model is giving, whatever prediction we are getting from the model, it should be very much correct. So first point is correctness. Second point is the model should be easy enough so that we should be able to analyze its output. If these two conditions are satisfied, means then we are saying that yes, the mathematical model is good. So system modeled in this chapter or in this module are linear time invariant systems. So if you are seeing a LCR circuit, you will be given some mass, damper and spring kind of modeling. So that is mechanical system modeling. All these models that we are going to see shortly are done by ordinary differential equation. And all these models are actually linear system model. So whenever we are writing d2x dt2 plus 5 dy dx, all those things, they are actually linear model. So LCR circuit model and MBK system model. MBK is mechanical system, mass, dashpot and spring. All those models we are going to see. Numericals will be asked in exam on that. So they are all linear system modeling. Now we are going to start with transfer function based system model. What are the transfer function properties? I think it was given, it was taken yesterday and lecture is uploaded. All these 6 points are given there. You can find out stability from transfer function. You can find out pole zero from transfer function. You can find out at which frequency the transfer function value of gain will be 0. You can find out which are the frequencies at which transfer function is going to have very high infinite value. All these things you can find out. So it is applicable only for LTI system. This is a downside of transfer function based modeling. If the system becomes nonlinear, in that case, this transfer function based modeling will give you inaccurate result. What are the advantages of transfer function based modeling? It is very easy method. Okay, it doesn't consider the initial condition in it, so we get a easily output. The system type, order, pole zeros can be easily calculated from transfer function. Transfer function depends only on the process parameter. It doesn't depend on the input. So all these things are explained in yesterday's last half-an-hour lecture. So yesterday I have uploaded 2 videos that was recorded by myself. First one was on DCS, digital communication system. Second one was done after you left the class and all. So second one video, please listen. It's a half-an-hour video. All the advantage, disadvantage, applications, features of transfer function based modeling was explained in there. It was all theoretical and one simple example we have solved there. So please check that. What is type of transfer function? A very important thing. There are mainly 3 types of transfer function. I think this video is visible from you. If you are having any problem at any time, please let me know. So these are 3 types of transfer function. So transfer function is output by input. If I find transfer function is given by HS, capital H bracket S. Transfer function is suppose this 1 by S. Okay, 1 by S is the transfer function possible. In that case, you are finding that numerator order of S is 1 and denominator it is a constant. That means numerator is 1 actually, and denominator the power of S is 1. So denominator S power. So generally transfer function is given in Laplace domain only. So denominator power of s is 1 and numerator power of s is 0 because it's a constant. Hence, this is called as a proper transfer function. So what is the characteristic of proper transfer function? You can find I have given three transfer function. Here s plus 1 divided by s square plus 3s plus 5. This is going to be a second order system. Okay, why second order system? Because denominator characteristic equation or denominator polynomial is having power of s as 2. So s square plus 3s plus 5 means this will be having two energy storing element. If it is a capacitive type circuit, then there will be two capacitors at least. Or if it's RLC circuit, there can be one inductor and one capacitor. So there are two energy storing element in this system whose transfer function I am showing. Hence, the denominator is having power of s as 2. Okay, it's a second order system. There are two energy storing elements. In this case, also the denominator power is 2 because it is s square plus 5s plus 6. Okay, s plus 2 is plus 3. So these are proper transfer function with system having two energy storing elements. What is the definition of proper transfer function? Numerator power of s should be less than denominator power of s. This is called as proper transfer function. What is meant by improper transfer function? If numerator power of s is greater than denominator power of s. So you are finding it is s square plus 3s plus 5 and it is s plus 1. Or I give you simply s. S can be also a transfer function. This is a transfer function of a differentiator. Okay, differentiator is having transfer function as s. Integrator is having transfer function as 1 by s. So 1 by s is a proper transfer function and s is an improper transfer function. Definition: order of the numerator if greater than the order of denominator. Order means order of s. Then we are calling that as a improper transfer function. What is strictly proper transfer function? Strictly proper transfer function, numerator and denominator power of s will be same. Example, s plus 1 by s plus 3, or here s square plus 3s plus 5 divided by s plus 1 into s plus 7. So in this case, you are finding s square plus 3s plus 5. This case, numerator power of s maximum is 2, and denominator maximum power of s is also 2. So this is called as a strictly proper transfer function. So these are actually the definition of transfer function. Now this is the example we had done yesterday. So find transfer function of the circuit. Here input is given VIT in the R1 R2C circuit. So first we are finding what is the input voltage loop equation. So we are finding VIT R1 plus R2 IT 1 by say integration of ITT. And then you are finding what is the Laplace. Laplace is R1 plus R2 into IS plus 1 by CS. And same we have found out for output R and C2. So what is the equation for the time domain? ITR2 plus 1 by say integration of ITDT. So this is actually uploaded in the lecture yesterday. PPT is also given to you. Please find it out. Then you are taking the V output equation at the numerator, V input equation at the denominator, and then you are cutting all the IS, you are cutting all the C and other thing. So they have finally got equation as 1 plus R2CS divided by 1 plus R1 R2CS. I have done some modification to it. So I have written it in the form of S plus 1 upon C into R1 plus R2 denominator. Numerator I have written as S plus 1 upon R2 into C. So in that case, you could find the value of S. So for numerator, we found S was equal to minus 1 upon R2C. So that we call as 0. S is equal to minus 1 upon R2C. That means if S is equal to minus 1 upon R2C, the numerator becomes 0. V output by V input becomes 0. So that frequency 1 upon R2C is called as 0 frequency, at which the transfer function is proper. So this is the definition of transfer function. Now we will see how we can find transfer function of a circuit.
Hello. So it is back. So now we are going to do the same finding transfer function. So do this numerical very well, very properly, because if you understand this numerical, understanding all other numericals will be easy. So what I am doing is I have given you. So last day I had given you previous whatever numerical we did. There was only one loop, that is the VIT and V output T. Now what we are doing is there are two loops. Okay, there are two loops, and we are asked to find out the transfer function in this case. Okay, so this is a circuit where we are giving V input T. So all are time dependent, time variable inputs. So this is VIT, and output is taken across this capacitor C. So this is called as V2T. So the output is V2T. This is not input, this is output, and input is V1T. So for V1T, it is getting divided, and across the capacitor, we are finding output as V2T. Now there are two resistances, R1 and R2. Okay, and there is one capacitor and one inductor. Now a lot of understandings are there. What all we can do? The first understanding is this is a network with two loops. That means it will be a little complex compared to the previous transfer function. And here the transfer function will be V2S divided by V1S, because V2S is the output and input is V1T. So if you take Laplace, it will be V1S. So we have to find V2S divided by V1S. And it will not be easy. There will be 3-4 steps intermediate. With that, we can find out. But main thing, before doing transfer function or before finding transfer function, we should know what is going to be the order of the system and why. Can anybody tell me what is going to be the order of the system and why? I'm expecting some answer from your side. Either you tell me or you write in the chat box.
Order is 2, sir.
Order is 2, very correct, Asutosh. And why is it so?
Sir, because inductor and capacitor, two elements are there.
Because the correct answer is, you are correct, you have understood it. The order of the circuit should be 2, because the circuit is having 4 elements, R1, R2, L and C, and 2 of them are energy storing element. So order of the circuit is equal to number of energy storing element in the circuit. Energy storing element L and C. That's why the order will be equal to 2. I have found out the transfer function. I'll tell you how to find the transfer function, but you can find out what is V output by V input. You find out what is V output by V input. So this is what is V output by V input. And what is the power of S you are finding here? It is S square. Okay, it is S square, and this is S square by S square. So whether it is proper, improper, or strictly proper transfer function, can you tell me, anybody? Whether it is proper, it is strictly proper. What is the definition of strictly proper? That power of S at the numerator and denominator, they will be same. So this is a, yeah, so they are a strictly proper transfer function. And main thing is, what is the characteristic equation? So whatever you are finding at the denominator, this equal to 0. That means LCR1 plus LCR2 S square plus CR1 R2 plus LS plus R1. This is equal to 0. This is the transfer function of that equation. And from there, this is a simple quadratic equation. By doing simple quadratic equation solution, we can find out two values of S1 and S2. So two values of S we can find. So this system will be having two poles. That means this system will be having two frequencies at which the overall gain of the system is going to be infinity. Okay, so I'll tell you now how to find it, and you have to practice it. वो एक दिन में नहीं आएगा, and all the numerical will be having same type, because in your exam more than 2 loops thing will not be asked generally. So maximum they can ask is 2 loop thing, but I can change the position of L, R, C, or number of L I might increase. So here instead of R2 I can add another L2, and in that case the order of the system will become 3. Okay, so I can add to the complexity, but maximum it will be 2 loop equation only. So this is a numerical very well you have to understand, and it does not require anything but understanding of what you have done in the first year or second year, that is series parallel combination. You only need to understand what is the series parallel combination in the circuit. Okay, So those who are still feeling little sleepy or hungry, maybe give your attention, because this is a numerical which we have to understand, because we will be solving a lot of electrical related numerical, but this is the type, or this is the same thing which will be repeated there. So this is one type you have to understand. So first thing, we will take the whole circuit into Laplace domain. Okay, and you can find there is only one node here. So VA is the main node, and VB is not the node, but this is a point. So we are mentioning it with VB. So VBA and VB, there are 2 points at which we are supposed to calculate the voltage. Okay, so we will be writing the voltage equation with respect to VA point, VB point, and all. What is the agenda? Agenda is to find what is the equation of V2 and what is the equation of V1 in terms of circuit parameter, and then we will do V2S divided by V1S. This is the main agenda. What we are doing is we are converting this circuit into Laplace. Simple it is. If it is C, make it 1 by Cs. So C is a capacitor. Whatever impedance it offers in Laplace domain will be 1 by Cs. So if I give you 2 farad, Laplace will be 1 by 2s. That's all. And whatever inductor is there, suppose 3 Henry, in Laplace domain you write it as 3s. Okay, because inductor is having kind of a differential kind of attitude. That's why L is given with Ls, and capacitor is having current in integrated fashion. What is the inductive current? Inductive current is given by L into dit by dt. Okay, that's why representing inductive voltage, there is coming a differentiation kind of current. So inductive voltage is L dit by dt. So whenever there is a differentiation, S will come. So that's why L becomes Ls. Itna hi jano kafi hai. We are not going to go too much into depth of Laplace transform. Only this much we have to understand. If L is given, we have to write Ls for that. If C is given, we have to write 1 by Cs for that. So C is given, it is Cs, L is Ls, R1, R2. R1, R2 is not a frequency dependent parameter. So whichever are reactive parameter like L and C, they are by Laplace transform. R is not a frequency dependent parameter. Hence R1 becomes R1 and R2 is R2. No change in that. V1t becomes V1s. V2t becomes V2s, and see that V2 is T is small but V2s is capital. V1t is small and V1s is capital. So after I do this example in this class at home, you should prepare. You should practice it 1 or 2 times. It's a request to everybody, because the same kind of numerical will be asked in the exam, and you have to understand not the numerical but the process that I'm using the numerical. Okay, that you have to understand. So this is now our modified circuit below whatever is there in the Laplace domain. Now we have to write 3 equations. What equations we will write? All the equations we will write in Laplace domain. First equation is how much is the output voltage. Okay, so how much is V2s, and everything has to be written in the terms of I1s. Okay, but immediately V2s cannot be written in terms of I1s, but V2s you can write in terms of I2s. Okay, so we are assuming 2 current. So this is the current, loop current I2s I'm assuming, and this is loop current I1s I'm assuming. So first step is write the circuit in Laplace domain. I have written that. Then assume 2 loop currents, I1 and I2. Then find out what is the voltage V2s across the capacitor. So voltage V2s across capacitor will be impedance 1 by Cs into I2s. So this is what I have written as that is I2s into 1 by Cs is equal to VB. And what is VB? VB is nothing but equal to V2s. So here it is written left side, VB is equal to V2s. So VB is nothing but a name I have given. Don't get confused with number of variables. VB is same as V2s. So what is VB or what is V2s? It is nothing but 1 by Cs into I2s. Or you can find out I2s from there. So current is equal to voltage divided by impedance. Now current is I2s through this capacitor is equal to voltage across capacitor is VB divided by impedance of the capacitor is 1 by Cs. Now in that case Cs goes above, so I2s becomes Cs into VB. Is this part understood? Anybody not understanding this? Please tell me. Sir, I could not understand how to write the equation of I2s. Everybody understood it? Only this equation, I2 is equal to, that is current flowing through this branch, is equal to voltage in this branch, that is VB, divided by impedance in this branch, that is 1 by CS. Or otherwise you can say that VB is equal to I2 into 1 by CS. From there find I2 VB divided by 1 by CS. And then take CS above, you are finding I2 is equal to CS into VB. Is it understood by all?
Yes, sir.
Okay, so can I go forward? So next step, I2 is equal to CS into V2S. So this is the first, actually I had to give here number 1 equation. Whenever you are solving it, so give this equation as number 1. So 3 equations we have to find. First equation is the equation of I2. So I2 is equal to CS into V2S, where V2S is equal to VB. Okay, now you can have a screenshot of this circuit with you. I'm giving you some time, you can have screenshot, because whenever I go to the next page, you will not be able to see the circuit. So just take the screenshot and it will be useful for you. Second is write down what is the equation of VA. Now here is coming the most confusing thing. People gets confused in this case. What will be the equation of VA? So VA can have 2 equations. Okay, is it understandable? Now the biggest statement I am making. Okay, is it understandable that this impedance LS is in parallel with series combination of R2 and 1 by CS? I will make the statement. Is it understandable that VA voltage, that means parallel voltage LS, this LS is in parallel with series combination of R2 and 1 by CS? So this is a parallel branch, R2 plus 1 by CS. This impedance is a parallel branch to LS. Is it understandable?
Yes, sir.
Anybody having doubt? Don't consider V2. V2 is just output we are taking. It is nothing. Don't consider V2. Abhi V2 bhul jao. Just think V2 is not there. Can I say that VA is equal to VR2 plus VB? VA is equal to voltage across R2 plus VB. What is voltage VB? VB is nothing but voltage across 1 by CS. So this VA is equal to, there are 2 ways of presenting VA. One is, what is the voltage across LS? So that is nothing but I1 minus I2 into LS, because I1 is flowing in clockwise direction, I2 is flowing in reverse direction. So net current through LS is I1 minus I2. So what is the voltage LS? I1 minus I2. So VA is nothing but equal to I1 minus I2 into LS. This is one way of explaining what is VA. What is the another way of explaining VA? VA is equal to I2 into whole into I2 whole into R2 plus 1 by CS. Because what is the current flowing through R2? Current flowing through R2 is I2S. What is the current flowing through 1 by CS? It is also I2S. So what is the total voltage of R2 plus 1 by CS? It is nothing but impedance multiplied by current. That is R2 plus 1 by CS whole multiplied by I2. So this VA voltage I can write down in 2 ways. This is the first way I have written it. This is the first way. This is the first way, means R2 into I2. That means I am writing first this parallel loop. So VA is equal to R2 plus I2. S you can write down. You don't write, it's also okay. So R2 is equal to, VA is equal to R2 I2. That is voltage across this plus voltage across capacitance, which is nothing but VB. So this first equation, VA is equal to R2 I2 plus VB. In that case, substitute VB is equal to V2S, because we have written VB or V2, anything you can keep. So R2 into I2S is equal to, substitute I2 as we have written at the top, CS into VB. So this I2S is substituted by CS into V2 or CS into VB plus V2S. What is V2S? V2S is nothing but the voltage across VB. So this first term, okay, R2 into I2S, and I2S is nothing but, we have found out CS into V2. So in the first term, we have first substitute R2 into I2, and I2 is equal to CS into V2 plus V2. So from here, if you take V2 outside, you will be getting VA is equal to V2 into 1 plus R2 CS. Is it understandable?
Yes, sir.
Sir, explain the equation of I1 as.
I1 I'm not explaining. Is it understandable up to VA?
Yes, sir.
It is easy. So VA is equal to R2, voltage across that is R2 into I2. That is the first step. Okay, there's the first step. And I2 I have substituted from the previous equation 1. Okay, that is CS into V2. Done. So the first voltage across R2 is nothing but R2 into CS V2 plus V2. V2 is nothing but VB. Okay, like this. Take V2 common. So VA is equal to V2 into S 1 plus R2 CS. Correct. Now, why can't you understand what is I1S? So I1S is equal to, so whatever is the current I1 is equal to VA divided by LS. VA divided by LS. So whatever is the current flowing through this. Okay, can I say this equation? Yeah, it is a little confusing. I will tell you. What is the net current flowing through this LS? Can I say it as I1 minus I2? Is it understandable? Net current flowing through inductor I1 minus I2. Is it understandable?
Yes,
Yes,
sir.
sir.
Okay. Net current in this LS is I1 minus I2. Fine. Can I represent current in terms of voltage and impedance? What is the voltage across LS? It is VA. Hello? Voltage across inductor, it is VA.
Yes, sir.
Understandable? So what is VA? VA is nothing but voltage at this point with respect to ground. So LS is connected between point VA and ground. That means voltage across LS is nothing but VA. Like here, we have found out. What is the voltage across capacitance? What is the voltage across
VB.
capacitance? VB, correct? So voltage across inductor is nothing but VA. Okay, so voltage across inductor is VA. And what is the impedance given by inductor? What is the
LS.
impedance given? LS. So voltage divided by impedance is what?
Current.
Current. So VA by LS is current. Here you can find out VA by LS is current. What is this current? This current is nothing but current flowing through inductor. Take this I2 in the left side. What does it become? I1 minus I2. What is I1 minus I2? I1 minus I2 is nothing but current flowing through this LS component. Is it understandable?
Yes, sir.
Yes,
Now,
sir.
now Ashutosh, this equation is clear. So I1 is equal
Yes,
to,
sir.
or I1 minus I2 is equal to VA by LS. This is you can write. Okay, so first step you can write as I1 minus I2 is equal to VA by LS, or second line, take the I2 in the right side, so you can find I1 is equal to VA upon LS plus I2. I think this equation is now clear. I1 is equal to VA by LS plus I2. Any doubt in this? Anybody? Okay, so can I proceed further? So I1 minus I2 is current flowing through the LS. LS is nothing but the impedance. And what is the actual current flowing through LS is nothing but voltage divided by impedance. So VA by LS is the actual current. That is equal to nothing but I1 minus I2. This is clear. Now, anybody having any doubt in this equation? Anybody having any doubt? I1. So I1 minus I2, that is nothing but the net current through LS. Voltage divided by impedance. So voltage by impedance is VA by LS, that is given by this current. I net, that is ILS, is equal to I1 minus I2. Now you have to keep on substituting, because you have to find now the I1 in terms of I2. So everything has to be found in terms of I2. So first you have found V2 in terms of I2. Now you're trying to find I1 in terms of I2. Just check. So VA by LS. So VA, now you are substituting from the previous equation. So in the previous equation, you can name it as equation number 2. So equation of VA, you can name as equation number 2. Equation of I2, you can name as equation number 1. So I1S is equal to V1 LS plus I2. And now you're substituting VA. What is VA? V2 into R2 CS plus 1. So this is divided by LS. So in this step, VA I have substituted as V2 into R2 CS plus 1. Okay, this numerator divided by LS plus I2. I2 you can substitute as CS into V2S. So if you take V2 outside, if you take CS into V2 outside or something, what we are finding is I1 also we are finding in terms of V2. Just check. I1 also in the previous step. Okay, so this step I1 is equal to VA by LS plus I2. Substitute VA as V2, you are finding like this. Take V2 outside, you are finding this. So I1 in terms of V2 you have found, and V2 and I2 they are related. Likewise. Okay, so I1 also you have represented in terms of V2. VA also you have represented in terms of V2. I2 also you have represented in terms of V2. So everything should be represented in terms of V2 or I2. Last equation, V1S is equal to R1I1 plus VA. Is it understandable? V1 is equal to R1I1 plus VA. Let's go back to the circuit. What is the current flowing through resistor R1?
I1S.
I1, correct hai? So V1S loop equation I am writing. I am writing the loop equation for the first loop. So what is V1? V1 is equal to R1 into I1 plus voltage across LS. What is the name of voltage across LS? Can I say it? It is VA.
VA.
Okay, so V1 is equal to R1 I1 plus VA. Is it understandable? V1 is equal to R1 I1 plus VA. Is it understandable?
Yes, sir.
Yes, sir.
Okay, so can I proceed to the next page? Because I told you, keep a screenshot. The same thing they have written. V1 is equal to R1 I1 plus VA. The same thing I have written. Now, in this also substitute I1 as this big term. Okay, because everything has to be represented in terms of V2. So if you can do that, VA you can represent it in terms of V2 like this. It is already proven. And I1 also you can represent in terms of V2. And this big equations, everything is represented in terms of V2. So first from the output loop, I2 I represented in terms of V2. Next, VA I represented in terms of V2. Next, I1 I represented in terms of V2. Why? Because V1 is equal to R1 I1 plus VA. Here you have done that. Plus there is another term which is called as VA. VA also you represent in terms of V2. Now what you do is take V2 common from all this and you are finding V1 also in terms of V2. So what are the relationship in the right side? So there are mainly 4 equations. Any circuit given, you should be able to write these 4 equations. All these 4 equations should be written in terms of V2. What is V2? V2 is nothing but the output voltage. Okay, so first you should be able to write down I2 in terms of V2. Second, you should be able to represent VA in terms of V2. Third, you should be write equation I1 in terms of V2. And fourth, V1 in terms of V2. So I'll repeat. I2 in terms of V2, VA in terms of V2, I1 in terms of V2, and V1 in terms of V2. So this is the step. So the circuit is given from left to right, but while solving, you have to start from right and come back to the left. So what is the first parameter very closely related to V2 is nothing but I2. So I2 is first represented in terms of V2. From there, you are finding this, that is R2 V2 is equal to VA. So VA you represented in terms of V2, I1 and V1 you represented in terms of V2. And when you are representing in terms of V2, what is the transfer function of this system? So transfer function is nothing but output voltage divided by input voltage. So output is V2, input is V1. Now you have represented V1 in terms of V2. From here, V1 is equal to V2. So directly you can find out what is the transfer function V2 by V1, and V2 by V1 you are finding as LS divided by LCR1 plus LCR2 into S square, CR1R2 plus L into S plus R1. And then you are finding what is the transfer function. So actually initially I told you wrong. That was the relationship between I2 and V1. So 4 questions I can ask. If you are having pen and paper, please write down. In the same circuit, I can ask you 4 questions. First question is, those who are having pen and paper, please write down. First question is, find what is V2 by V1. So whenever you are sitting for this lecture, have pen and paper and have calculator with you. So first question is, what is V2 by V1? So V2 by V1 is nothing but transfer function, output voltage divided by input voltage. Very important thing. Second, I can ask you, what is I2 by V1? What is I2 by V1? You have studied it in 2-port network. Can anybody tell me? Output current by input voltage. What do you call it? It is written here in the screen. You can find out. I2 by V1. What is this thing called?
Impedance or admittance.
It is called impedance or admittance. Current by voltage is called as admittance. And it is called transfer. Why transfer? Because you are relating the parameters of 2 different ports. So I2 is the output port and 1 is the input port. So I2 by V1. So I by V is admittance. And whenever you are relating the admittance, current and voltage of 2 different ports, the word transfer comes there. So transfer means I from one port and V from another port. So it is called as transfer admittance. So you have found out I2 by V1. Can I find I1 by V2? So that is the third thing you can find out. Write down I1 by V2. So first I can ask you to find out V2 by V1. Second thing I can ask you, so V2 by V1 is transfer function. Second, I can ask you I2 by V1, that is current by voltage of two different ports. Next, I can ask you I1 by V2. Can you find I1 by V2? Check that. Already we have found out in this equation at the top I1 in terms of V2. So what will be I1 by V2? So just take V2 at the denominator. So I1 by V2 will be R2CS plus 1 plus LCS square divided by LS. So you can find I1 by V2. And what else you can find? Can you find I2 by I1? Can you find I2 by I1? What is the relationships? I2 I have found, just check the previous slide. I2 I have found as CS into V2S. And what is I1 I am finding? I1 I am finding again in terms of V2S. So I2 is nothing but CS by V2S and I1 is V2S by LS divided by this. So whenever you do I2 by I1, just take this one at the numerator, that is CS into V2S, and put the whole thing in the denominator. Okay. So what you will be getting is something like CS divided by R2CS plus 1 plus LCS square divided by LS. So this is nothing but I2 by I1. What is I2 by I1 called, by the way? Anybody? What is I2 by I1 called? I2 by I1 is called as a current gain. V2 by V1 is called as a voltage gain, or V2 by V1 is called as a transfer function, and I2 by I1 is called as a current gain. So how many parameters I can ask you? I can ask you to find 4 parameters. First function. Second parameter, I can ask you to find I2 by V1, that is the transfer admittance. Third thing I can ask you to find out is I2 by I1. I2 by I1 is nothing but the current gain. Fourth thing I can ask you to find out I1 by V2. So I1 by V2 is also admittance, it is transfer admittance. So these 4 parameters. Has anybody written down? So first is V2 by V1, second is I2 by V1, third thing is I1 by V2, and fourth thing is I2 by I1. So current gain, voltage gain, transfer admittance port 1 and transfer admittance at port 2. All those things I can ask you. If I ask you V1 by I2, you should be able to calculate, because here you are finding I2 by V1, just flip it. Okay, you will be finding V1 by I2. So V1 by I2 is called as transfer impedance. I can ask you to find out V2 by I1, that is also transfer impedance. So many this ratios I can ask you to calculate, and you should be able to calculate, but rule is the same. So last 2 minutes is remaining. I'll just tell you again the same numerical with rule, and I'm not going to solve any more numerical on this. Okay, I have told you everything and I have told you how to calculate. Now I can ask you difficult numericals, but the process will be same. Whatever you do, the process you have to keep same. Don't change the process. So try to understand the process, not numerical. So first step, you have to find what is V2 and define what is I2. So V2 is equal to 1 by CS into I2. So from there represent I2 in terms of V2S. So V2S is nothing but VB, that is nothing but the output voltage. So I2 is equal to CS into V2S. Next, you have to apply the property of parallelism. That is, whatever is the voltage across LS, that will be the summed voltage across R2 and 1 by CS. So VA is equal to LS into I1 minus I2, or VA is equal to I2 into R2 plus whole 1 by CS. So VA is equal to R2 plus 1 by CS if we take. So VA is equal to R2 I2 plus VB. That is, VA is equal to R2 I2 plus VB. There you substitute what is the value of I2 from the previous equation. So you are representing VA in terms of V2. Third equation, yes, it is little difficult to understand at your level. So what I am writing is, I am writing the current voltage equation across impedance LS. So net current flowing through impedance LS is I1 minus I2. That is equal to VA divided by LS. So current is equal to voltage by impedance. So I1 minus I2 is equal to VA divided by LS. Take the I2 right side. So you are getting this equation. I1 is equal to VA by LS plus I2. Now represent VA in terms of V2 from the previous. Now represent I2 in terms of V2s from the previous. So you are finding I1 representing in terms of V2. So everything has to be represented in terms of V2. Lastly, you are finding what is the equation of V1. So V1 in this circuit is nothing but R1 plus I1 plus VA. VA is nothing but voltage across LS. So V1 is equal to R1 I1 plus VA. Now you are having all those parameters in terms of V2. So R1 I1 plus VA. VA you are representing in terms of V2. R1 is a constant. I1 also you are representing in terms of V2. So if you are taking the V2 common, you are finding V1 is equal to something of V2. Then you just find out what is V2 by V1. And if you are finding V2 by V1, what you are finding is it is equal to Ls divided by something of S square plus something of S plus R1. What we can find out is the denominator equation or characteristic equation is having two poles. That means this is a second order system. Looking at the circuit, you can find out there is one inductor and one capacitor. That means this is a second order system. So whatever thing we have defined initially and whatever thing we are finding in the transfer function, both are matching. That is, there are only two energy storing element and characteristic equation is having order 2. System is a second order system. Lastly, I can ask you to find many combined parameters. I2 by V1, I can ask you to find V1 by I2. I1 by V2, or I can ask you to find out V1 by I2, or I can ask you to find out current gain I2 by I1, or I can ask you to find out V2 by V1. So there are 6 parameters which you can find out from this numerical. So many different circuits will be given to you. You should be able to find what is the transfer function of those electrical circuits. So this finishes modeling of electrical system. Now I will give 2 or 3 numericals to you. You have to solve and you have to submit it in the group. So it is not OBA, it is not IA, it is just simply a solving kind of practice kind of numerical. So I'll be posting it in a day or two. You just prepare it and submit it. So the topic will be modeling of electrical systems. So next day, that is someday, whenever it comes next day, we'll be starting with transfer function modeling of mechanical systems. So transfer function modeling of electrical system is over. You can find the book of Gopal. You'll be finding numericals. We'll start with transfer function modeling of mechanical system next. So this PDF will be uploaded. Thank you. That's all from my side now.